So we've got some technical folks in the room probably, right? Data scientists? Oh, not that many data scientists. Just computer scientists. Cool, I mean, that's very broad. Non-technical folks. Oh, a couple of us too, okay, cool. Well, as mentioned, my name is Daniel Huss. Not particularly technical, so I will be not forwarding your technical questions. I will do my best. You can throw them my way. However, I did run data science as head of product for one of the largest financial institutions in the world. I built a number of AI products there. I was a lead product manager. Somehow got thrown into being the lead product manager for everything data science related at Boston Consulting Group. And for the last 6 years, I've been running this company, gravityAI. We're a venture-backed startup, technically based out of New York, but most of my team is here in San Diego. At our core, we are MLOps at the end of the day. Last 6 years I've been running this. And despite all of those accomplishments, for the most part, I would say that my core friend group does not necessarily think of me as being a very mature individual. And I think that it could be a short joke, as in I'm not full grown, which I take deep offense to at 5'6". We're very, very testy about that. But it also could be related to the fact that in order for you to be mature, you will have reached an advanced stage in a process, which I've neglected so much of my process as an adult. Taxes, family, I've got a startup. But this is very interesting because we are talking about the AI maturity curve. The maturity curve being advanced in this process across understanding AI. And I know that there are some data scientists, some engineers in this group, some non-technical people, and I'm just going to tell you right now, I am using AI as the rest of the world is using AI right now. So what do I mean by this? Well, there's a running joke. When you're talking to a venture capitalist, it's AI. When you're talking to an executive, it's machine learning. And when you talk to someone who knows what they're doing, it's a very simple statistical model. So when I'm referring to AI here, just to get this out of the way, I'm talking about receiving a set of inputs, and that goes through some sort of algorithm. I don't care your technique, and you're going to get some outputs from that. Are we in agreement that we do? Oh, cool. Thank you. I appreciate it. Yeah. Okay. It's obviously, this is a contested area. We're using AI everywhere. It's AI washing. So as far as the AI maturity curve is concerned, why is this important? Well, this helps us gauge where we are in our growth and process to being able to implement this kind of thing. And every maturity curve that's ever come out, digital transformation, our SEO and personalization maturity curve has a set of factors. One of those factors is that it's got a clear set of dimensions, right? So where you are at the beginning of your journey and where you are at your end of your journey. And in between, those things are a set of capabilities, the things that help you get from the beginning of your journey to the end of your journey. So that's essentially what we're talking about right now with the AI maturity curve. And one example of the beginning of your journey for one curve is you could be doing ad hoc AI. And at the other end of the spectrum might be innovate, as in this particular example of a generative AI maturity curve. Not the most helpful one that I've ever seen. I don't know who created this. It's fine. It's okay. On one side, we've got using generative AI on an ad hoc basis. And then on the other one, now this is something that we're using to drive strategic advantage. But this doesn't necessarily help us understand how to move across that process. Another example from Gartner is I'm aware of AI, and I don't know how you couldn't be at this point, versus the other end of the spectrum is that this is some sort of transformational capability that we now have in our business, and that one looks like this. Little more helpful, but still not particularly actionable. We've got different levels across the top. I think level 3 here is probably the most important in that we are finding a way to be operational, to productionalize what we've created, which is a big part of where most machine learning and AI initiatives have fallen short. Something like 85 to 87% of most machine learning projects at enterprise have failed to ever make it into production, according to Gartner. Still not the most helpful. One that I do like, though, has us labeled as a laggard versus a leader. And by no means am I going to walk through all of this, but you can literally Google, like I did for this presentation, AI maturity curve, and you're going to find this. Don't worry. This is pretty cool. At one end, we've got our laggards, we're leaders, and across the different circular regions here, we've got beginner, we've got being responsive and proactive versus leading, and there's actually like a true sense of some of the things that you can do as someone who's running a company or someone in tech or someone who is working on process or talent to actually advance yourself across this curve. I do encourage you to look at this one because it's quite well done. So what I think, if I were to simplify all of the information from that and boil this down into like my own version of this without having spent the time to create a nice graphic, because that was a nice graphic and my designer has better things to do. A mature org basically has 3 things. You need AI that is accessible, so accessibility. You need to be adaptable, and you need accountability within the way that you're structuring this. Why these 3 things? 1, 3s are easy to remember, more so than 2s and 4s. That's why it's 3s. And also, alliteration's cool. That's literally the only reason that I picked those 3 things, other than that it naturally lines up to the things that I actually do care about. So what does that actually look like in practice? Accessibility. If you're a mature organization, accessibility means having the ability to distribute what you've built as a data scientist. So this is your, in its first form, your Python code, in its final form, probably an API or a user experience layer, to the rest of your organization. That's essentially what this means. This is your classic anti-silo talk, right? From an adaptability standpoint, it's very difficult to talk about AI right now because it's changing literally from week to week, as we know. It's changing extremely fast. The performance of the models that you might be using today, you might go grab a new open source model that is infinitely better than the one that you're using today and retrain it. We might need to use different techniques. Adaptability is, do I have the capabilities right now to future-proof what I'm doing so that if something new, cool, better comes around, I can update my existing infrastructure and processes to reflect that. That's the adaptability. In addition to all of the kind of operational rollout capabilities. And then extremely important, often neglected, is the accountability side of things, which is, are we adhering by ethical AI standards, right? Things like transparency, checking for bias, all the other 8 ones that I literally talk about all the time. This is extremely important because, 1, not just because it makes you a better organization and better human beings, but because you have to do this now. The EU just launched the AI Act, and while my perspective of the AI Act is mostly favorable, it's a mess, and it's going to be very difficult to implement. The US has a slightly different approach around accountability, and I literally just was in Vegas last week talking about AI at the AI4 conference, and I met the congressman in charge of the AI task force to build the US's legislation. So rather than the approach that the EU took, the US is going to launch one bill for 10 years as this adapts, rather than one giant bill that we hope lasts 10 years. So regardless of whatever our stance is on this, we are going to have to get ourselves in line with this, even if you are the smallest company right now. We are going to have to learn how to manage regulation and adapt to it, beyond just being a good person. So all of this requires alignment across numerous things. Your tech stack, this is going to require alignment of your talent and updating your training and making sure that everyone within your organization understands the types of complications that we have, both ethically and from a tech perspective. And we're going to need a bunch of process updates, like change management. These are the core things that ultimately lead us to our final form of AI maturity, that final place that we want to reach, adulthood, if you will. We're only going to talk about this one today, because all the other ones are going to require an entirely different... Am I coming back for all the other ones? Maybe it's a different session. No, we're just talking about tech today, and we're going to try to break down the various types of technologies that we need in order to get further across our maturity. So I adapted this from a very, very good presentation from Gartner. This is your final form, and I'm going to go through most of these things. Not all of them in great detail, but I will take questions, maybe. First, this is your initial stage here. So your logical data warehouse, this deserves an entire one of those. This diagram could be even bigger for that single little thing, logical data warehouse right there. But you're going to be, in some way, shape, or form, you need somewhere where you're ingesting data, right? From there, you've got your data science toolbox. This, on the open source side of things, might include things like Jupyter Notebooks or Zeppelin. This is where most data scientists are going to be doing their activities, most likely on their machine, like locally on their machine. Then you've got your classic code repositories. These are your GitHubs of the world. Then in model training, this is where we are actually going to take our data and try to train that model itself. Some open source possibilities of this would be like Spark, Ray, Horvath. These are different things, tools that data scientists will use to ultimately try to create a model. And then we're going to run model inference. The term inference is just a fancy way of saying I've ingested my inputs and I'm going to get my outputs out of that. That's all that means. Other than my training data, which is in the step before this. This, a little baby level. And yes, I found a baby Gundam just for this presentation. This is not scalable. This is basically your R&D process as a data scientist. This is what you're going to be doing to try to find something that has predictive value among your data, or fine-tuning and playing around with a large language model, whatever it might be. It's extremely manual. You cannot productionalize this. This is really kind of your first stage that if I want to try something and run a POC, this is probably what I'm going to be doing. Let's expand this a little bit. From here, I'm going to add some stuff. We've got packages now. And I don't mean like packages in the way that data scientists predict, well, kind of. Like packages are different ways that like you might actually drop something into the data science that you're working on, code packages, Python packages. What I mean here is a model packages where we're actually solidifying up what we're doing, containerizing it, for example, using Docker, Kubernetes. This is a step that I think gets pushed onto data scientists a lot at organizations. Oftentimes, this is a big ask for data scientists because it's typically not part of their education. They're not necessarily taught to do DevOps. They're not necessarily taught to do containerization and API building. But this is frequently something that is pushed onto them anyway. Many data scientists can obviously do this, and many do. But for the most part, this is something that we're asking of data scientists that we probably shouldn't be. Next would be, how do we advance our model inference? How do we begin to run this at more scale? Well, now we're thinking about turning this into an API instead of maybe just a batch process where we're running one set of data through some model that we've created. Now we can do on-demand data. So think of every time you thumbs up and thumbs down something on Netflix, that is changing the core model itself and making new decisions as far as personalization is concerned. And probably the most important thing here is that at this point, because we've kind of solidified our pipeline, we have a better opportunity to actually run this within the context of software in some sort of app that we've created. In the previous example, that's really just we're doing a POC, right? We're not running this at scale in some sort of piece of software, because AI at its core is just a feature, and it's going to have to exist within some broader context of software itself. Teenager. That's what we got here. Still not great. Still very manual for a big portion of what it is that we're talking about here, but at least we've integrated it into some sort of actual working software at this point. Not scalable. We cannot continue to do this if we're going to exist in today's world without more infrastructure, because we are almost certainly going to need to continue to experiment and integrate these things more and more into the software that we're building. This works for a few models. Let's say 10 models. Other than that, you're going to be spending an enormous amount of time, and it would have been better for you to have built the infrastructure out to actually allow you to scale. Finally, updated from a model package to a true model repository. So this is somewhere that you are storing all of your production-ready models, the things that you are going to be calling with an API, or someone is going to be accessing through a UI layer. We can automate this process, taking Python code, Julia code, R code, all of the code that data scientists typically use, uploading it into a model repository. The modern ones will typically automatically do the job of the model package process, automatically containerize it, build a set of API endpoints around it. Oftentimes in these model repositories, you have pre-trained models that then you can access and customize. And when you're running inference on those, in this type of situation, you can have automated deployments. You can, with a couple clicks of a button with this type of technology, spin up and spin down the instances that will then allow you to run large language models at scale, AI art generation at scale, a personalization model at scale, whatever it might be, with a couple clicks of a button. And finally, I'm not going to spend a ton of time on this, but this is your how do I customize at scale part of this pipeline. This is your transformers repository and feature store. Transformers is a fairly broad category that data scientists will care a lot more about than the rest of us. But these are the types of tools that allow us to architect or customize pre-trained models. In some cases, they are pre-trained models themselves. And features are a fancy word for the parts of our data set that have predictive power that we're going to actually use to make predictions or use to actually drive the outputs that our model is utilizing for those predictions itself. A feature store is not necessarily a true store where you're purchasing features. This is literally I'm storing a list of, think like columns across an Excel spreadsheet, storing all the things that have that predictive power. Oh my God, that's the name of my company. How did that get in there? This is what we do. So I am a little bit partial to this part of it. And this part of the pipeline is actually one of the most neglected. We do spend a lot of time on the R&D side when probably we should be spending a lot more time on the actual repository and inference side of things, because running your model inference, is how you get it to the hands of your end users or your employees. This is your adult level. Now I'm leaving off orchestration and monitoring a little bit. I'm happy to answer some questions around that. But at this point, if we are trying to do numerous deployments, and now even deployments of some of the more complicated types of models, again, like large language models, open source models like Llama 3 or Mistral, this is almost now a requirement for that. Even if you're not building and launching thousands of models. At this point, we have stability. You can roll back a container if something breaks. Who heard about the recent lawsuit against Air Canada and their chatbot? like 4 of us. So I'm just going to talk about this very briefly. Air Canada launched a large language model chatbot, and an individual was communicating with that chatbot on their website about a refund for a bereavement policy that they had. And the chatbot, using probably Llama 2 or Llama 3, made up a completely unique, nothing related to Air Canada's actual policy for giving a refund for bereavement. This went to court, and Canada's court decided that this particular model was a representative of Air Canada, and they refunded that gentleman his $847.26 plus legal fees. So not a massive particular loss for Air Canada, but when we talk about being able to customize these and roll them back and do this at scale, when your software breaks, you need the ability to roll back a version or make updates very, very quickly. And it's no different when you're trying to launch a model. So when we are talking about running things at scale, we need to be able to have version control, roll back our large language models, make sure that we make updates quickly in a pipeline like this, and be able to distribute them and roll them out without all of the other overhead and processes. It's your adult level. Adult Gundam. In summary, this part of your pipeline, this is your R&D process. From a talent perspective, this is typically what has been done by data scientists in the past. Again, they've been asked to do a lot more than this. You're full stack data scientists, but this is typically what the role of data scientist would do, the building of the model itself. This part is a data engineer plus your data scientist figuring out all of the core data that you have that you're able to leverage to customize, to have ultimately new models and be able to build those new models and customize them at scale. And then finally, what's been called the sexiest title of the 2020s, your ML engineer, has typically been responsible for rolling out the processes of your model repository and your scalable deployment of those models, in addition to orchestration and monitoring of those individual models themselves. So this is something that, even as startups or large organizations, this is not one of those things where like this is some sort of trend that's going to break. This is something that we have to be doing now. So if you want to accelerate things like accessibility, adaptability, and accountability, well, that's why I built my company, gravityAI. Again, we are that core one section. I'm going to leave it at that. If you need any help with anything that you guys are doing or want to talk about infrastructure, I'll talk your ear off. I love talking about it. I also sit on the board for 2 AI ethics organizations and a Future of AI Skills board. So if those are questions that you have, I'm more than happy to talk about that as well. Thank you.